Hi everyone, welcome back to another video. Today I am going to talk about algebra, and in particularly I am going to discuss the topic of factoring. A lot of students have difficulty with factoring, where to start and which method to use. Now I did a video previously on which method to use based on the number of terms that's given to you if GCF cannot be used. Looking at this expression here, we cannot use the GCF because there's no number that can go into each of the four terms. And there's no variable that can go in each of the four terms because one of the terms doesn't have a variable. This is a monomial constant because a monomial constant is a number that stands by itself. Now, we're going to use the grouping method when we are given four terms. Now, the word grouping alone tells you a lot. It means that you're going to group these four terms. You need two groups. So let's get started. We're going to rewrite this with two groups. So we have a 3n to the third power minus 4n to the second power. I put a stroke there to separate them, and you can put the plus here or you can drop it and leave it because it's positive. All right, because if it was negative, then you would have put it there. So it's up to you if you want to put the plus or if you want to leave it as leave it out. That's fine. So we have two groups here. Okay, good. Now we're going to use the GCF method, right? And the GCF method is when we are going to look for a number that is greater than 1 that can go into each of the two numbers or two coefficients of the two terms. So there's no number that can go into each of the two coefficients, which are 3 and 4 of the two terms. So we cannot take a number out. But looking at the variables, right? We have n to the third power and we have n to the second power. We can take out the one with the least or the lower exponent, which here would be n to the second power. So we're going to take out n to the second power. Okay, now one thing I must say to you that not every expression has a variable x. In this case you have the variable n. It could be any letter of the alphabet. Okay, so we have our n to the second power here, and now I am going to say 3n to the third power divided by n to the second power. So there's no number, well, it would be an invisible 1 if you want to say that. 1 into 3 is simply 3, okay? N to the third power divided by n to the second power. We're going to apply the law of exponent. And the law of exponent states that for given exponents, right, we're going to, and we need to divide exponents, we're going to keep the base and subtract the exponents. All right, so we're going to keep the base, which is n, subtract the exponent. 3 minus 2 is going to be 1. We're not going to put an invisible 1. You do not use an invisible 1 for exponent, just the same way you do not use the 1 in front of the variable as a coefficient in essence. You do not place that 1 there. It's invisible. You make it invisible. All right, so now you have negative n to the second power left. We're going to divide that by n to the second power. You're just going to get negative 4, and you close your parentheses there. This is the first group that you have factored out using GCF. Now let's go to the second group. The second group, now we have 9n and negative 12. There's no variable beside the 12, the negative 12, because the negative 12 is a monomial constant, so we cannot take out a variable. But we can, let's look at it. Can we take out a number? Yes. Even if it's 1, if it was given a situation where it was just 1 that you could take out, or 1, in a sense, you take out the 1 and put it there because you need it. And I'm going to do a problem on that too. But in this case, you can take out 3 can go into 9 and 3 can go into negative 12. So I'm going to take out my 3. There's no variable, as I told you, that I can take out. So 3 into 9 is 3, and then you have the variable n. 3 into negative 12 is negative 4, and you have that. Now look at what is inside the parentheses. You will notice that both of these terms or both of these binomials inside the parentheses are the same. Once they are the same, you are going to simply write them. All right, take them out first. Write them as a set of binomial. Once you have that, then you're going to look at what is outside the parentheses, okay? And you're going to write it together inside of a parentheses. And this is a positive 3 here. And you have it like that. Now, this is the answer, but I always tell my students, write your answers in standard form. So in order to write this in standard form, you are going to simply rewrite the problem where you have the highest exponent written first. So n to the second power plus 3, and then parentheses 3n minus 4. All right, and then I always tell my students, please box your answers, or I like to be fancy, so I put a cloud around my answers like that. Okay, now I also encourage my students to check their work, because you want to be confident that yes, you got it, and yes, this is correct. So to check your work, all right, I always multiply using the FOIL method, all right, my first terms together of each of my binomial. So n to the second power times 3n, I'm going to get 3n to the third power. Now O, that was the first terms I multiplied. O is going to be, and I'm going to do another video on this, okay, sidebar. O is going to be now the first term with your outer term. So n to the second power times -4 is going to be -4n to the second power. And then I'm going to do the under piece, and the under piece, I'm going to multiply this inner with the first one. So I have 3 times 3n is going to be positive 9n, and I multiply my last terms together of both. 3 times -4 is going to be -12. And then you look back at your original expression that's given, and you'll notice that you have the same expression. Then you can say, woo, voila, I got it. Okay? So that's what we have, and that would be your answer. Now, there is another situation where I want to show you, what if your middle operation here was negative? And I'm going to do an example like that for you, so you know what to do. And because there are some students out there who have problems dealing with negative numbers, and I'm going to illustrate to you what to do if you had a negative number there. All right, so let's get right into it. Start out with I'm going to use my x this time, 2x squared minus 14x to the second power minus 3x, and this is going to be plus 21. All right, so let's get into it. So first thing, as I stated to you before, you're going to rewrite it in 2 groups. So I'm going to rewrite this in 2 groups. So I'm going to have 2x to the third power minus 14x to the second. Draw the line down to show that you have 2 groups here. All right, notice I'm bringing my negative with me also. Then after that, now you take out your GCF. I am going a little bit faster now that we know it. Take out our GCF. Our GCF that can go into this set of band in both terms is going to be 2, can go into 14. So it's going to be 2, and then you x cubed and x squared, take out the x to the second power. So I'm going to be left with simply 2 into 2 is 1. We don't put a 1 there. X cubed divided by x squared is going to be x, and then 2x squared into negative 14x squared is going to be 2 into negative 14 is going to be -7. X into x squared cancels out. Then from this other group, the second group, I am going to take out negative. Always take out negative if the first term has a negative there. Always take out your negative. Then you look and see which number can go into both. The 3 can go into both. A -3 and it can also go into 21. So take out the negative, you're left with x, and now you're saying 21 divided by negative 3 is going to give you a negative number. It's going to be negative 7, because negative divided, positive divided by negative give you a negative, or negative divided by positive going to give you a negative answer. Once again, you're going to look and you are going to notice that inside the parentheses, that binomial, those two binomials are the same. If they are not the same, then you have done something wrong. And a lot of people usually mess up here with this negative, right? So be careful, because they might want to put a positive here, and then you'll notice, oh, but this one is negative and this is positive. That's when you catch yourself. Please be very careful there, okay, with the negative. So we're going to just now, whatever these two binomials that are the same, we're going to rewrite that first as our first term, and then we are going to combine what we have here for what is left back, 2x squared and the negative 3, and we're going to write it as another set, minus 3. Now, once again, as I stated, I always tell my student, please write your answer in standard form. So you're going to have 2x to the second power first, minus 3, and as one parentheses, and the next one is x minus 7 as the other one. And I like to box my answer, and I tell the students, please box your answer. You're telling whoever is grading your paper that that is the answer that you need to be graded on. And always check your work. Okay, always check your work. So you are going to multiply the first term with the other first term of the other binomial together. You're going to get 2x to the third power. Multiply the first with the last term, okay, and that is going to give you negative 14x squared. Then you are going to multiply the last term of the first binomial with the first term of the last binomial. You're going to get negative 3x, and then you multiply negative 3x with the last term, both last terms together. You're going to get positive 21. Now you look at the term here, look back at your original expression, notice that you get the same thing. Then you can put a check mark, voila, and you can then submit that as your answer. I hope this has helped you in knowing where to start when you're given a polynomial, right? Which method to use. Once you have 4 terms, and you cannot use GCF, use the grouping method. Okay, please watch my other video on which method to start with when you are given a particular expression, whether it's a monomial, a binomial, a trinomial, or a polynomial. Thank you for watching. Please like, share, and subscribe, and I'll see you soon